everybody.
Hello,
Hello,
hello.
Andre.
Hey guys.
So while we're waiting for everybody to join, I'd like to say a few words about this new Neon series called Builder's Demo, where we showcase some of the amazing projects from both the Ethereum and Solana networks and invite their creators and developers who can show hands-on how to use their projects to become better developer, to improve your own projects, and to, in this case, learn how to test your Solana programs. So today we have a special treat. This is a great project called Trident. Trident and Andre here created this incredible fuzzing framework that sounds even I think that is going to work even more fun than it sounds. And this framework allows you to test Solana programs with all these random data inputs and basically see the changes in the state of the programs to find some unexpected bugs early on. So, hi, Andre. How's it going? Could you tell us a few words about yourself before you jump into Trident and fuzzing?
Yeah, sure. So, hello guys. It is a really pleasure to be at this Twitter space and to talk to you, to show you the Trident that we created in the Eki. And yeah, my name is Andre. I'm the lead auditor at a key blockchain security company. We basically do the security audits and then we try to really improve the ecosystems, both Solana and EVM with our tooling. So namely the Trident, we have Wake in the EVM ecosystem and bunch more such as Solana, VS Code and Cursor extension, etc., etc. And apart from that, we also run the School of Solana, which is meant for the beginners and the newcomers into the Solana ecosystem. So yeah, that's basically overview from my side, from our side as a key. And yeah, once again, happy to be here.
We are incredibly lucky to have Andre here, who is not only a lead Solana School of Solana instructor and also comes from Eki blockchain security, but is also actually a creator of Trident. So we are going to see the how to work with Trident from first hands, and this is a really great opportunity to learn how to test Solana programs in this very interesting way. So I'd like to give the word to Andre and stop interrupting him from now on, maybe only with a couple of questions a bit later on. But let me remove my screen and you can share your screen.
All right, so I will stop sharing. Yeah, so you should see the presentation, hopefully. Yeah, it is there. So once again, welcome everyone. Yeah, as was said, I'm going to present the Trident and I will shortly talk also about the VS Code extension, which is meant for the static analysis and also visualization of code coverage during the fuzzing. Don't be afraid. I will tell what the fuzzing is, what are the different approaches of the fuzzing. I will show you where you can find the Trident. I will show you how you can install it, what are all the resources such as documentation, repository, etc. It is really helpful to have such resources because what we aim to build with the Trident is some framework such as testing framework that is used within the Anchor. So that means it should be really simple for you to write the fuzz-test. But of course, we understand that wrapping your head around the idea of fuzzing might be difficult. So that's the core idea of this presentation, to basically describe you what the fuzzing is. So welcome to the Art of Manually Guided Fuzzing with the Trident. The introduction was already there, so yeah, I'm the lead auditor at Eki. You can see my Twitter handle, so feel free to drop me DM and we can chat about different various of stuff. So yeah, that's possible. And I'm also lead School of Solana lecturer, but shout out also to my colleagues who take care at the moment within the School of Solana, and they communicate with the students, prepare the materials, do the revisions, etc., etc. So the first question is why we actually need fuzzing. So as you may know, the Solana ecosystem grows, same is with the Ethereum ecosystem. Both of the ecosystems grows in terms of the TVL, in terms of the market cap of the stable coins. Recently, tokenized assets were added to both of the ecosystems, so EVM, also the Solana, so you can directly buy S&P 500 on the Solana or also on the Ethereum. Same goes with different stocks. So the blockchains are becoming the internet capital markets where all of the funds are located. For that reason, we definitely need to increase the security on both sides. For the Trident specifically, I will talk more about the Solana, but this applies also to the Ethereum ecosystem, where we are developing the Wake, which is also the manually guided fuzzer. So this was kind of inspiration for the Trident. What we need to do is to increase the security. So, for example, integration tests are not enough, and we need to stress test the smart contracts deployed on the Solana and also on the Ethereum. In this case, stress testing, we can ask what the stress testing is or what the fuzzing is. So there is a simple sentence about the fuzzing, and the fuzzing or fuzz testing is a testing technique that provides random, valid, invalid, or unexpected input data to your programs. And this helps you to discover unknown bugs and vulnerabilities. In other words, when you test your smart contract on Solana, in this case, for example, you write the anchor test, there is sequence of the instructions, you test the happy paths, that's a happy path means the expected scenario, and you test a few unhappy paths. So you can check if this instruction returns error for such input data, etc., etc. These are all of the paths in your smart contract that you expect that will happen. On the other hand, with the fuzzing, you are trying to input completely random data to the instructions, or it can be completely random account addresses to the instruction. You can try also completely different sequences of instructions. This is also part of the fuzzing, which is part of the Trident. You can, if you try to think about the fuzzing, I have this very simple meme. So a tester in a bar orders beers. He tries to order 1 beer, 2 beers, 3 beers. That's pretty valid, pretty normal. But then he tries to order 88 beers or 0 beers or minus some big number of beers, some big amount of beers. Basically, the tester tries to do anything. That's the idea of the fuzzing. And there are, in principle, multiple types of the fuzzing that you can have. In the down left corner, you can see I have mentioned the black box and gray box fuzzing. And these are one of the types. Then we have the manually guided. But the black box means that the fuzzer does not know anything about the destination, about the program that the fuzzer trying to fuzz. So in this case, you have the Solana program, which has some kind of interface. So what are the instructions? What are the parameters to instructions? What is the number of accounts on the input of the instruction, etc., etc. Maybe what are the constraints for the accounts, etc. Black box fuzzer, in this case, would send completely random data to the instruction and check what is happening. This can be really useful because it covers the whole space of the data that can be sent to the program, to the instructions. On the other hand, in a vast majority of cases, it would produce errors and issues, and actually nothing would be fast within the program because there are a lot of strong conditions and constraints for the accounts, for the addresses. So great example is that the Solana pub key is 32-byte long address. And if you send always completely random address, in most cases, 99.9%, you will not find the right address in order to just proceed into the instruction. So in this case, black box fuzzing is not the greatest idea because 99.9% the instructions would fail at the start, and in principle, you would not fuzz the body of the instructions. Within the gray box, this is improved because gray box fuzzer has already some kind of knowledge. So for example, for the Solana programs, it can be the interface. So gray box fuzzer can know, these are the instructions, these are the input parameters, there are some booleans, unsigned 64 bits long integers, etc., etc. So don't generate me completely random data, completely random stuff, but generate me such data as are within the IDL, as are the interface to the program. That's better. On the other hand, for example, for the Solana, there are multiple reasons why it's still not enough, but it's better. One of the reasons is that, for example, the Solana programs at this time, most of the time, accept some kind of logical sequence of instructions. So if the program contains something like initialize, then initialize user account, initialize user account, deposit, withdraw, swap, add liquidity, borrow, or something like that, you can expect that the initialize will be always called first when the program is deployed. First and once. Then, most likely, there will be initialization of a few users, so initialize user. So there will be initialization of 1, 10, 5, 100 users. And there will be executions of swap, deposit, withdrawals, and borrows, liquidations, etc. So what I'm trying to explain is that at the start, you just call the initialize once, then you initialize 10 users, and then you do this set of withdrawals, deposits, etc., for example, indefinitely or for some high amount of times. The gray box fuzzer would not know about this. The gray box fuzzer, for example, knows just about the interface, but does not know that initialize should be called first, not the withdrawal. You cannot withdraw when there were no deposits yet. You cannot withdraw if the initialization was not yet executed. And gray box fuzzer does not know that. So that's one of the examples why the gray box fuzzer is better than black box in this case, but still not perfect.
Okay, and can I ask a question? Yeah, what about manual fuzzing? Is it the next logical step from black box to gray box to manual fuzzing to just have a more guided approach?
Sorry for the pause. Exactly. What we started to work on is the manually guided fuzzing. You can see on the meme that the tester adds to the orders, or the orders have some kind of preconditions. So the tester knows that on Monday he shouldn't drink. So in that case, he orders 0 beers. On Tuesday, less than 5. On Friday, he tries to be more experimental, so he experiments with a lot of numbers. And that's the art of the manually guided fuzzing. What's the con here is that it is not so black box. So as I said at the start, the black box does not know anything about the system, or you as a user does not need to know anything about the system. That's pretty nice, because in that case, you just start black box fuzzer and there is no work required from your side. In this case, it can be like a disadvantage, because for the manual guided fuzzer, it is required that you actually write some source code, some tests. On the other hand, we think there are much more advantages which, exactly solve the issues that I described previously. So we can utilize basically something like the gray box fuzzer, where we know the interface, plus we add the knowledge that the source code is, for example, public, or the knowledge of the developer of the smart contract. And in that case, he can write the fuzz-test by himself and manually guide the fuzzer. What are the advantages? it is dedicated to the protocol needs. So for example, from the perspective of the developer of the smart contract, if he tries to manually guide or fuzz the smart contract, he knows what are the like dangerous spots in the smart contract. Of course, there might be some that he is not aware of, but let's say there is some kind of math. He knows that he should focus on this part of the smart contract. For example, as I was talking about the example with the withdrawals and the deposits, he knows that he shouldn't fuzz the initialize, because the initialize is pretty simple and there is nothing to fuzz. But he knows that the withdrawals and the deposits are more important to fuzz, because these are the places where the assets and the funds of the users actually flow. Covers edge cases. All right, in this case, this would be the same for all of the types, also for the black box and the gray box, because the fuzzer will try the whole range of the numbers or the inputs. Mimics real-world environment. This is pretty useful because I was talking about the interface in the context of the black box or the gray box, but it might be more difficult. And for example, I'm not sure about the Ethereum world, but on the Solana, we have something like CPI, cross-program invocations. And if you just put the fuzzer, which would start fuzzing and start using different input parameters, different instruction accounts, etc., the fuzzer does not know about the CPIs, does not know about the specific accounts that has to be taken from the mainnet or specific programs that has to be taken from the mainnet. On the other hand, the manually guided approach, the developer knows about the CPI into the Camino or CPI into the Jupiter, or I don't know, the proprietary automated market maker. In that case, the developer can specify in the manually guided fuzzer that, all right, take this from the mainnet, even if it's program or account, take it from the mainnet and use it within the fuzz-test. And the fuzzer then can perform the CPIs. And what is also important is that there are no approximations. It basically tests how the program behaves, because we don't need to update the source code, do any kind of approximation, take parts of the source code and execute them on some different places. You just deploy to the light client, to the Trident SVM, the smart contract, which can be done in the Trident, and then that's basically how it works. It is executed as with the real behavior. And as I said, there is this one disadvantage. Okay, let me drink, please.
Thank you. And maybe I can ask a follow-up. You mentioned some of Solana specifics like CPI calls, for example, that influence how you would approach fuzzing. And would you say that there are some particular bugs, some particular types of bugs that arise from Solana's specific account model? And can fuzzing help exposing those specific Solana-related, account model-related bugs?
Yeah, sure, definitely can, because with the manually guided fuzzing, you can specify that on the instruction input, there are accounts. And you can specify that sometimes you want to use the correct account and sometimes you want to use not the correct account. These times on Solana, I would say what the developers do is most of the time they know about the issues, that because you need to, as a developer, ensure some relationships between the accounts. If you don't ensure the relationships, some users may lose funds, for example, or their assets. These days, I would say developers are starting to be skilled with these constraints, and they specify the constraints correctly. So we don't find these type of bugs often. On the other hand, what happens recently, what's starting to happen recently, or what we can see is happening, is the lack of knowledge, for example, with the SPL tokens and token 2022 programs, because there is, I'm not sure if I can say it is legacy version, but there is this older program which is called SPL token, and there is this newer version of the basically same implementation with some additions, which is called token 2022. And there is initiative to support them somehow together with their interfaces. And what we can see is that even though the users or the developers can correctly specify the relationships between the accounts, they forget or they lack of knowledge how to correctly specify these constraints for the SPL tokens and the token 2022 programs or token accounts, mint accounts, etc. And this can be definitely easily found by fuzzing, because within the fuzzer, you can specify that you want to use token account which belongs to the SPL token or token account which belongs to the token 2022. And what you can find is that, for example, you think your smart contract supports both programs, so SPL and also token 2022. You think that, but with the fuzzing, you discovered that there is some kind of issue with the token 2022 program because you are missing one constraint in the smart contract. And that's basically what we can see recently in the smart contract. Of course, as I started with the constraints and the relationship between accounts, this can be also found with the Trident. On the other hand, these are not that often these days.
Okay, thank you so much. Yeah. Have a look at those constraints.
Yeah, I understand that for some developers, it might be also hard to find how the constraints should be used, because I'm specifically talking right now about the Anchor framework. I'm not completely sure if everything is well documented. What I can remember for a few months ago, not everything was completely correctly documented. So yeah, implementation is correct, but documentation is lacking. And yeah, so in that case, you need to have a look in the Anchor source code and check how it is implemented there. So yeah, I can see why it is problematic, but we are trying to solve it with the fuzzing. Regarding the Trident, so what it is first things first, pretty simple, Rust-based CLI tool. So if you are using terminal, which you probably do, if you are writing Solana programs, you need to execute Anchor build, for example. In that case, Trident is similar. You can use commands such as Trident init in order to initialize the fuzz-test, or Trident fuzz in order to start fuzzing. The Trident creates the template. When you initialize the Trident within your project, it creates a Trident tests folder and initializes first fuzz-test. This first fuzz-test is something like template for writing the fuzz-test, and it is derived from the IDL. I would like to add there that in principle, we also support within Trident the vanilla Solana programs. So programs not written in the Anchor, but using the vanilla Solana. Also Pinocchio. On the other hand, when you are writing the Solana programs with vanilla Solana, not with the Anchor, there is no IDL. I think there is tool for deriving IDL also from vanilla Solana programs. It is to be honest, I think it is not yet so established, but it is possible to generate IDL. And in that case, you can create the fastest template. In principle, for vanilla Solana, support is already there, but we are not able to generate the IDL from the vanilla Solana program. So in that case, the fastest template. That's kind of unfortunate, but if you manually initialize it, it's completely all right. It's up to you. What also Trident provides is the fast execution. Some of you may recognize Light SVM. So we have implemented something similar. It is called Trident SVM, but Light SVM is much, how to say it, has much more functionality. The Trident SVM is just dedicated to the fuzzing right now, but definitely there are plans to expand the functionality. Multiple features to cover real-world environment. So you can execute multiple instructions within one transaction. You can forward in time. That's not real-world behavior because you cannot skip into the future. But yeah, in the Trident, you can forward in time. You can implement the invariant checks. That's the stateful fuzzing. You can dump programs and the accounts from the mainnet or from the devnet. So that means you are testing the real behavior, no any kind of approximation. We have also the dashboard that can be helpful to help you to analyze the outputs of the fuzzing. We find it helpful, for example, for the clients when we do the security fuzzing for the clients. and we want to present the results, we can show them the dashboard, and the dashboard contains information about how many transactions were executed, how many were successful, how many failed, how many undesired reverts, if there were invariant checks which failed, what is the entropy of the inputs, etc., etc. Stateful fuzzing, yes, stateful fuzzing means that, for example, the token accounts that I was talking about, you check the balance of the token account, and based on the balance, you fuzz the deposit. So if the user has 10 SOL, you are not trying to deposit 50 SOL. Yes, it might be useful, as I showed in the previous slides, that you should cover all edge cases, but in most cases, it is nice to try it, but you don't want to waste time on fuzzing 100 SOL if the user has 10 SOL. And invariants basically are comparing the behavior in the fuzz-test with the behavior of the smart contract. So the accounts are updated in some way, and in the fuzz-test you check if the update is actually correct. So for example, for the token account, if there is transfer happening from token account A to the token account B, the amount should be deducted. Why is it useful? Maybe, for example, if the mint accounts are using transfer fee extension with the token 2022 program, you would see that the amount deducted, amount deducted is the whole sent amount, but the amount received is the amount transferred minus the fee. So in that case, you can see that, for example, this can break the mathematical model in your smart contract. All right, that was about the Trident. Now I would like to briefly talk about the VS Code extension that we have. Are there any questions?
Well, I was curious about invariant fuzzing. The last point that you introduced, invariant checks, because it seems that would be one of the main maybe things to check when you're moving from EVM logic to Solana logic, which Neon basically does. It executes EVM bytecode within Solana runtime, and it has all these libraries that basically create Solana instructions from Solidity code and Solidity functions. So I'm guessing that invariant checks would be very important and basically even critical maybe for translating logic from EVM to Solana.
In principle, I think so, yeah, because you can basically compare the behavior. You can take the account before the transaction, after the transaction, and you can check if the changes are as expected within the account, because that's the main principle on Solana. On Solana, there are no storages directly within the smart contracts, but we have these data accounts. These are just the address and some value on that address, and that some value is basically the storage. And you don't update the storage within the smart contract, but you update the storage within the account. So yeah, you can take the account before the transaction, execute the transaction, you have the state before, and then take the account after the transaction. Now you have the state after, and compare if these changes that are made into the storage, if they are expected.
Yeah. Thank you so much. That's an amazing check.
All right. Moving forward to the VS Code extension, VS Code/Cursor extension, because the extension is available also in the Cursor marketplace. That's, if you don't know what the Cursor is, that's the code editor with the AI in it. So yeah, that's the Cursor. I have also a meme for the VS Code extension. VS Code extension is basically based on the experience of the audits from the Solana ecosystem. During past few years, we noticed that there is this kind of gap. We understand that there will be criticals, there will be high severity issues, mediums with maybe business logic, etc. On the other hand, we noticed that there is a lot of small hanging fruits, a lot of warnings, low severity issues, which in some cases can even cause criticals and highs. So we wanted to fill the gap. You can see the meme. Most of the developers are like, yeah, the audit will resolve everything, but both of the sides I think are totally correct, not the middle one. And the left side is that you as a developer should ensure the security of the smart contract. You should check your code. And the right side is that you should perform all of the available security testing stuff that is there. So fuzzing, definitely integration tests, but there shouldn't be program without integration testing nor fuzzing, because that's the fundamental security part. And the static analysis. The static analysis, I would say, okay, the static analysis is harder, so it may create false positives. So false positive means it will detect something that is not actually issue. But with the integration testing and the fuzzing, you should definitely implement this. All right. There are also formal verification, which can be also pretty useful. So we wanted to fill the gap, and what that means. The static analysis. There are already some tools on the Solana that provide static analysis, but they are CLI tools. Even though they can be really useful and really helpful, they are CLI tools in these terms. And static analysis connected with the CLI tool is not perfect, because you receive list of the issues found, and if there are, I don't know, 1,000 of issues found, some of them may be false positives, so it is hard to analyze what is false positive, what is true positive, etc. With the VS Code extension, you just download the extension, and you can directly in the code see underlined source code, and if you hover over the underline, you can see that warning, I don't know, unchecked arithmetic used, this can overflow, which will panic, which will create denial of service, users mad, okay? Or warnings with unnecessary accounts, or we have this detector about mutability. That's also a pretty common thing that is happening during the audits. I don't think I need to go into the detail because that would be a long explanation about the issue. But yeah, we think this might be really helpful to just perform the static analysis before the audit. You can see we suggest some of the issues that can be fixed. And instead of reporting 25 issues in the audit, we will report just 20, because the 5 were fixed before the audit using the VS Code extension. And the second feature, what is implemented in the extension, is the code coverage. So the Trident is the fuzzer, but sometimes you want to see which parts of the smart contract actually were visited by the fuzzer. And for that, the code coverage can help you. So I will show you in the hands-on example on the smart contract. If I run the fuzzer with the code coverage enabled, you will see that this kind of instruction is executed, I don't know, 400, 500 times. And then in different instruction, you can see also the number, and you can see all of the branches, all of the requires, all of the if statements that were executed and how many times. That's it from the presentation. Any questions?
When you said that you have an extension also for Cursor, I just started thinking, well, is it probably going to help for vibe coders who try to vibe code a blockchain app, or is it still a very, very bad idea to vibe code a blockchain app?
If you want to vibe code of course, it will help. I would say that for 100% it will help, because it can definitely cover or find, uncover or find issues, some of the issues. On the other hand, as I said, when we released, or as I was trying to discuss, when we released the VS Code extension, it's not the end, it's rather the beginning, because there is always room for the improvements, and we want to improve the detectors. That means if you vibe code the Solana smart contract and you don't know much about the Solana, it is most likely that the VS Code extension will show you some issues, but you may have a lot of criticals and high severity issues, which may result in loss of funds or loss of assets of users. So in that case, I wouldn't say it is a good idea to just vibe code and then deploy and then market it, because users can lose funds, and I would say you don't want that.
Yep, and that's from a security specialist, guys.
Maybe I would add to that, If you want to use AI to help you, that's all right, but there is still room for improvements also with the AI. So don't just rely on what AI tell you. Going for it may sound strange because I'm from the security company and maybe I want you to have audits, but from my experience, AI will make mistakes. So it is still better to go for the audit if you are vibe coding with the AI and if you told the AI to check the source code.
Yeah. Maybe even more so.
Yeah.
Yeah. Thank you.
Okay, so right now, if there are no other questions, I will stop sharing and I want to talk about the resources. So where you want to where you can start with the Trident. So the first thing is let's start with the repository. So if you type into the Google Solana Trident, I would say the first link is to the Trident repository. If you find GitHub of the Eki blockchain company, the Trident is public within the GitHub. There are a few repositories, so you can also easily find the Trident repository there. And yeah, you can contribute here. You can check what we are working on right now. The structure is really simple. We have master and develop. Within the develop branch, we have not yet published changes, and the master is what is currently published. And that's basically it. You can check the pull requests, and there is room for the discussions and also room for opening the issues. So if you have any kind of issues with the Trident, feel free to open. If you have questions, it is better to go to the discussion section or to the Discord and ask questions there. Within the issue section, just write the issues that you have with the Trident. Also, you can clone the repository, and the repository contains makefile. So if you clone the repository and if you in the CLI execute the make install, the Trident will be installed from the local copy from what you cloned. Just okay, that's the repository. Then the second resource is the documentation. So we have also the documentation for the Trident. So if you are not sure how to use the Trident, what are the method calls, API calls that are within the Trident, how to deploy some programs from the mainnet or accounts, you can navigate to the documentation and check within the documentation. There is versioning in the documentation, so you can also navigate to the dev and see the latest changes that we are planning to publish, where you can find the documentation eki.xyz/trident/docs. So that's basically everything about the documentation. Of course, as I said, you can contribute. Some people already contributed. We have some number of contributions. So if you find any kind of issues, for example, also with the documentation, you can contribute again also on the GitHub. Now, last resource that I would like to show you is the crates.io. So maybe you are aware of such web page. There is this crates.io web page where you can, for example, look for Solana SDK crate, which you may know from the testing perspective. But in the same way, you can look for the Trident CLI, the Trident crate. In this page, you can see how to install the Trident. You can see the versions. You can see the dependencies. This is particularly helpful if you want to find out what versions of Solana, for example, the Trident uses, what versions of SDK, etc. If you navigate to the specific version, the install command will change. So in this case, you can install the specific Trident version with this command. If you want to install the maybe small addition, if you want to install this pre-release version, that's what we released a few days ago. You can see 4 days ago. Currently, it is pre-release. When we decide to release it as a normal version in the upcoming days or weeks, you will see it there. If you just use the Trident CLI command without the version, it will install the latest full version published, not the pre-release. All right. So if you want to try the pre-release, you need to specify the version. That's it from the resources. Let me see what is the time. Okay, 20 minutes. Let me share you the fuzzing. And give me a second. Okay, I have it. Okay, you can see the source code, right?
Yeah.
Yes.
Could you maybe make it a bit bigger?
Sure thing. Like this, or is this enough?
I think even bigger.
So I can do this.
Yeah.
Is
yeah.
it enough?
I think this is good. Yeah, at least
This
for my view. Yeah.
This would be too much, I would say. And it is not that important to see what is in the source code, I would
Oh,
say.
okay.
It is just to have overview. For the example, I will not write the whole fuzz-test from scratch. I don't think it is necessary. We have examples in the repository there that I just showed you. So if you navigate to the examples folder, there are a bunch of examples, and one of them is this one that I'm just presenting. If I open the CLI, I'm presenting the one example, which is from the examples, Trident benchmark, and it is Maze 0. All right, so Maze 0 from the Trident benchmark example within the repository. Just quick notes to this. I think this benchmark is even taken from the Ethereum ecosystem. I don't know the exact name. It is some kind of it is Maze. So it was taken from Ethereum, I think, and we rewrote it to the Solana. Okay, you can see basically the source code of regular Solana program. We have initialize method, we take the state, update some values, we have move node method, which accepts some values that we will use to move to different areas, then move south, move east, move west. At this point, you want to start testing or fuzzing. You want to start fuzzing your smart contract. In that case, you just call Trident init. Okay. I have already fuzz-test written, so it will tell me that it is skipping because it looks like Trident is already initialized. How do I know that it is initialized? There is this Trident tests folder. I have already written the fuzz-test, but what the next thing you can do is the Trident fuzz add. Okay, it will build a program. I should build it before the meeting, but it will build the program in order to generate the IDL and basically prepare another fuzz-test template here in the Trident tests. So here is fuzz 0, and when this is finished, there will be fuzz 1 basically, which will be empty. Then, when it is generated or initialized, within the Trident test folder, there are multiple files when you open it. So we can start, for example, with the trident.toml. This will be mostly empty. This is added for the coverage extension, but it will just contain these few flags. Even this JSON and dashboard will not be enabled, and it will just contain the fuzz metrics. The fuzz metrics do that after the fuzzing. You can see table in the CLI with the results. So this results mean this transaction was executed this amount of time, this amount of time it failed, this amount of time it reverted, etc. Let me see. There is some compiling issue. All right, maybe I made some change in the source code. It is not important. Important is it would just generate another fuzz-test, fuzz1 with the empty fuzz-test with just the fuzz-test template. So Trident Tomo, then cargo.tomo. You don't, in principle, need to add anything there. You just have the binary target. So this is the fuzz-test. If another fuzz-test is added, automatically there will appear fuzz1 with basically this, but instead of 0, there will be 1. And that's it. All right, regarding the fuzz-test template itself, the most straight thing is the types.rs. So if you have experience with writing the anchor tests within the TypeScript, this is something similar. So the anchor generates IDL and also types.ts, or I think it is type.ts for the TypeScript tests. We have something similar, but with the Rust. That means you can utilize these types in order to call the instructions or transactions within the test fuzz.rs. But before we move to the test fuzz.rs, I would like to show you the fuzz accounts.rs. And this file just contains storage of addresses. I will tell you more about the storage of addresses in the test fuzz. In this case, you just need to know that there is this there is this storage of addresses for every account that appeared within the IDL. It is by name, so most of the time it can create duplicates. It is not that important. It is really simple to not to use them at all or just remove them. Okay, test fuzz. I will scroll down and start with the main. So programmers know that the main is basically the starting function. When the main is executed at the first when you start fuzzing. Here is the entry into the fuzz test, which contains two numbers, 1000 and 100. The first number is how many iterations during the fuzzing you want to execute. The second number is how many random flows you want to execute. I know flows is something that I was not talking about yet, but this is the number of flows that you want to execute. This is the manual guidance, and if you are familiar with the wake, you maybe already understand what the flow means. So this is similar to the wake framework. All right, now about the flows. What it means to have the flows. You could notice, and I was talking about the random sequences of the instructions during the presentation, and sometimes you want to have the initialize first, and then you want to perform the deposit, the withdraw, etc. In this case, in this smart contract, we have initialize first, and then we have some navigation during the maze, or through the maze, sorry. And we want, with the fuzzing, we want to bring randomness to the navigation. So we want the random selection of the instructions, of the movement. So we don't want to always move to the north 10 times and to the south 5 times, but we want these movements to be completely random. So for that, we have the flows. What it means to have flows. You can see here is the first flow, which is the method called however you want, but it has to be marked with the flow attribute. And within this method, we perform just one instruction, and that is move north instruction. You can see the move north instruction is taken from the maze, from the types.rs file. So you can use the types to create the instructions, and then you can use the Trident to process. It is called transaction because it contains vector or array of instructions. So the array is turned into the transaction. All right, back to the flows. You can see this is the first flow, and the second flow is moving to the south. And to put this together, as I said down below, there is this number of flows, which is 100. That means within each iteration, from 1000 of iterations, the fuzzer will create completely random sequence of flows. The amount of flows will be 100 in every iteration. What's the result? The result is that completely random sequence of move south, move north, move east, and move west instructions. So you are basically creating random sequence of random movement in the maze. Every iteration has completely unique sequence of these instructions. If there is 100 flows, that means, as an example, it will be executed like flow 1, flow 1, flow 1, flow 2, flow 4, flow 3, etc. until 100. And the second iteration will be the same thing, but with different sequence. And that's used to bring randomness to the instructions. On the other hand, as I was speaking about the parts of the initialize, deposit, withdraw, and at the end, sometimes we want to basically maybe claim fees or something like that as admin or author or some authority. That's where we have two different methods, starting with the init or start method decorated with the init. And here, what you do is that you just initialize. And this init method is executed at the start of each iteration, but just once. So you have 1000 iterations at the start. First, this init method, then 100 flows, random sequence, and then at the end, after the 100 flows, the end method. So method decorated with the end attribute. In this case, we are not collecting fees. There is nothing to execute at the end, no garbage collector or rent collector or something like that. We don't need to execute nothing. So you can see the body of the method is empty. Okay, I will drink water. Now, important thing, or is there any question? Are there any questions?
I have one question. Just how is it different from Wake? I'm guessing that it should be different because it's Solana, and it should take into account, well, basically the account flows and some sort of instruction flows. And yeah, if you have time, that would be nice to know.
Sure. There are a lot of differences, but there are a lot of principles that are basically the same. I would say the flows in principle are the same. On the other hand, first example, Wake is written in Python. I think, hopefully I'm correct, but yeah, I'm almost sure that it is written in Python, and maybe some parts are written in Rust. That's the first thing. In Python, you have much more options than in Rust. On the other hand, I would say the Rust is safer. That's the first difference. The second difference is basically two different ecosystems. As I was talking about the storage in the smart contract, in the Ethereum, you have storage in the smart contract. Hopefully I'm correct. And in the Solana, you have storage in the data accounts. What it means? In this case, you can see there is this state. All right. So in Solana, you need to specify all of the storages basically that you want to read or which you want to update in the smart contract on the instruction input. On the other hand, in the EVM, I think there is just the caller or sender or something like that, which is one address that is sending the instruction. So from this perspective, I would say maybe on the Ethereum, it is much easier because you just keep track about the sender. On the other hand, and that's where the account storages are handy, is that for each account within the IDL, based on the name, we create the account address. And why is it helpful? Is it helpful because at the start of the fuzzing within the init method, we put random address to the account storage, which is the state author. Then we use this state author, something as a caller of the initialize instruction. And then if we need to use the same address, or maybe different, if you want to use the different caller, that's basically fuzzing to try to use valid or also invalid input data. Then here in the flow one, you can take it from the state author storage, but instead of insert, you would call get. All right. What's maybe important to mention is that if you just insert once, there will be just one address. If you call get on the storage with one address, you will always get the same address basically. If you want to try different state authors in the flows, what you can do is to call, for example, in a for loop 10 times this insert. That would mean it would add 10 addresses into the storage, and then within the flow you just do one get and it will obtain one address from the storage. And what's the magic here? The magic here is that one address is correct and 9 of them is incorrect or are incorrect. In this case, you are actually fuzzing. What is happening if I send the correct address to the smart contract and if I send the 9 incorrect addresses to the smart contract? It doesn't need to be 9. It can be 5 in total, so 1 correct, 4 incorrect. Yeah, and you are observing the behavior, what is happening basically with the smart contract when there is incorrect address and the correct address. Hopefully this was a long explanation, but hopefully it was...
Yeah, great. Thank you.
Okay, what's the time? We have 3 minutes. Okay, so one last thing I think that I would like to show is the code coverage. So because that's pretty nice to see, pretty nice visualization. So let me see. I'm currently in the fuzz-test. I need to have the extension. So Solana, you can see it is installed. Let me open this. There are also settings, so you can update the port, you can update the colors. That's just the overview, not need to do that before the fuzzing. And as I'm here, the Trident toml should contain this part. Everything can be found in the documentation. So we are enabling the coverage. We specify the server port. You can notice that this port is the same as within the settings. And now I can just call Trident. Trident fuzz and the name of the fuzz-test. So fuzz0, if you have 10 fuzz-tests there, you just call the correct name. All right, you can see some outputs already. So it is fuzzing. And if I navigate to the lib.rs, you can see some indicator here that we are basically 46% into the smart contract. And you can see already some numbers. The fuzzing was pretty fast. I will comment on the outputs here. The fuzzing was pretty fast, but you can see the initialize was executed 993 times. What is more appealing or important is, for example, this move north. So it was executed almost 25,000 of times. You can see it is pretty fast because it was running for 12 seconds. So this instruction was executed this number of times. And then in the instruction body, you can see that this require has basically 2 options. The first option is that this condition is met, or the second option is that this condition is not met, so the error is returned. And you can see the indicator here from the coverage that the second branch basically, or the second option, was executed 2,000 of times. Then the remaining 22,000 or 22,500 of times, we continue within the instruction body. And same applies to the rest of the lines. So with this, you can basically see where everywhere the the fuzzer was within the smart contract. One note here is that why is this number just 46? We are within the anchor, or we are within the smart contract, which is written using the Anchor framework, and Anchor provides a lot of macros. And not everything is reachable within the macros, within the source code. In that case, coverage is smaller. Okay, so that's basically it. We have this indicator. I would say it will be really hard to achieve 100% there. So what is better to observe is are basically the parts of the source code, the instruction bodies. Regarding the output from the fuzzing, you can see some progress bar and you can see some table. So you can enable this table within the Trident toml with this fuzz metrics enabled with the true, with the first line here. And you can see, this is just more for the debugging, but you can see that the initialize was executed almost 1,000 of times. That can be read also from the coverage, as I was talking about. there is the success, and you can see the instruction did not fail or did not panic. On the other hand, for example, the movements, what is important is maybe this last thing, and that's the instruction panic. And why is it important? Because you, as developer of the smart contract, you don't want the instruction to panic, because that's something undesired. Maybe it's unwrap or it is overflow which panic, but you don't know what's the behavior. And these undesired panics can create the denial of service equals users mad if the denial of service. Imagine you have deposited assets somewhere and you cannot withdraw them because denial of service occurs due to the overflow, which is panicking. And you need to, the developers need to manually intervene the production, redeploy the smart contract, and you are mad because you couldn't withdraw the assets. So that's what is basically happening here. So instead of just the correctness of the smart contract in the terms of math, you should also focus on these undesired reverse of the transactions where the panics are occurring and transactions are reverted and you don't know why. It's really important. Yes, that's everything from my side.
Yeah, it would be so nice if the same VS Code extension could fix these issues.
Yes. We are trying to work on that. So hopefully we will reach a lot of great additions in the future.
Yeah, absolutely. And even revealing these issues so early on before going to the auditor is an amazing saving of time and effort. Thank you so much, Andre. I really loved your presentation and demonstration. I learned a lot about fuzzing. And I hope that everybody, learned as well. Yes.
Also, thanks that I could be here. I also enjoyed the stream. I enjoyed talking about the fuzzing. I enjoyed talking about the work that we are doing in the IQ blockchain security. So yeah, looking forward to your DMs and to your issues open on the GitHub. As I said, if you want to contribute, feel free, guys. And yeah, if you have any questions, DM me, write on Discord, have questions. We are open to that. And yeah, hopefully Trident will secure a lot of new protocols.
Yeah, go Trident. And if you want to demonstrate your own project in the same builders demo, then fill out the form. We have the form for that. Oh, we are going to find you and we are going to reach out to you. Thank you so much once again, Andre, and have a great evening.
You too. Thanks, Neon. Thanks, team.
Cheers.
Bye-bye.